So there are actuators that need analog voltages to do what they need to do, need to be controlled with analog voltage, but an Arduino or most microcontrollers cannot supply analog voltages directly. So instead, it is common to use pulse width modulation. So there are many actuators that normally take analog voltage, but you can basically fool them with a pulse width modulated signal. And pulse width modulated signals can be generated from Arduinos and from most microcontrollers. So basically, what a pulse width modulated signal is, it's the idea that, look, we assume we can only output digital, 0 and 5 volts, 0 volts, 5 volts, let's say. So how do we fake out, essentially fool the actuator to think that it's getting some arbitrary voltage in between? Say we want to supply it with 2.5 volts, right? But we can only give out 0 and 5 volts. So what we can do is just alternate between 0 and 5 volts very quickly. So we output a square wave, 0 volts at the bottom and then 5 volts at the top. And if it's a 50% duty cycle, so if it's high half the time and low half the time, then on average you'll be sending out 2.5 volts. And now whether that works or not depends on the actuator. But if you make this square wave go very quickly, have a high frequency, and then your actuator doesn't respond quickly, right? Normal actuators don't respond that quickly, then this is satisfactory. This will work. And that's usually most actuators. There are a lot of actuators that will accept pulse width modulated signals as a replacement for actual analog voltage. So you're sending out a square wave, 0 volts, 5 volts, but the thing that you're changing is the pulse width, basically what percentage of the time the signal is high. So a duty cycle is a percent of the time that the pulse is high. So if you have a 50% duty cycle, that's the middle signal waveform that you're seeing there. It's high half the time, low half the time. But if you want the perceived voltage to be higher, then you have maybe a 75% duty cycle. And then you get what you see at the top, where it's high 75% of the time, so the average voltage is going to be higher. Or you could go down 25% duty cycle, then the average voltage is lower. So you can change the perceived voltage by changing the width of this pulse. Now, analog write does exactly this. It generates a pulse width modulated signal. So it generates a square wave on a pin. It's 490 hertz. Now, hertz is cycles per second, right? So how many clock pulses? 490 clock pulses every second. That's how fast this clock is changing, how fast the square wave is changing. This analog write takes two arguments. First argument is a pin number, the pin that you want to generate the pulse width modulated signal on. And just as a note, Arduino only allows you to generate the pulse width modulated signal on a subset of the pins. If you look at your Arduino, the numbers of the pins, there'll be a little tilde, a squiggle mark next to the pins that you're allowed to do pulse width modulation on. Okay, so the first argument is the pin number. Second argument is the pulse width, or an indication of the pulse width. So the second argument is a number from 0 to 255, and that number indicates how wide the pulse is. So 0 means you have a 0% duty cycle, which means it's low all the time. 255 is the max, so that would mean 100% duty cycle. If you wanted 50% duty cycle, you'd do halfway in between, so 128 or 127. That'd be 50% duty cycle, and you can change the duty cycle by changing that second argument. The pin number has to be a pulse width modulated pin. It has a little tilde symbol. They're marked on the Arduino. So an example, you might say analog write 3, 128. That would say on pin 3, we're going to drive that with a square wave. And 128 is its duty cycle. Now, since that's halfway between, or almost halfway between 0 and 255, you'd expect a 50% duty cycle for that. Now, here's an example piece of code. This is actually in your example. So if you open up your Arduino IDE, go to File, Examples. I believe this is in the Basics. File, Examples, Basics. There's one called Fade, and that's this. I've taken out all the comments to make it shorter, but this is basically the code. So first, notice there are the normal two functions is set up in the loop. All this does, just to zip right to what it does, there's an LED. It assumes that there is an LED connected on one of the pins. Actually, I must have left out that. LED is a variable in here that refers to a particular pin that you've wired an LED onto. Let's assume it's pin 13, okay? So LED's pin, say it's pin 13 because we know there's an LED on that pin. So what all this does is it calls analog write on that pin. You can see highlighted in red. It calls analog write on that pin. So it generates a square wave on that pin. And the second argument, which is the duty cycle, which is the indication of the duty cycle, that's the brightness. So the idea is, if you have a large duty cycle, 100% duty cycle, then you're going to get a very bright LED. But if you have a very small duty cycle, if it's only high a very small fraction of the time, then you get a very dim LED. And so what this function does, if you look at the loop, it does the analog write with a certain brightness, starting out at brightness 0, so it would be off. Then it increments brightness. Brightness equals brightness plus fade amount, which is something small, say 5, okay? Then if brightness equals 0 or brightness equals 255, so if it's reached an extreme, so let's say you're counting up, right? So you start off with brightness equals 0, then 5, then 10, and so on. Every pass through, because this is in a loop, it gets bigger, brighter, and brighter. Then once it hits the maximum, once it's 255, then it has to change direction. And the fade amount should, if it was 5, it should become -5 now, so that it gets dimmer. And then if it was -5 and you hit 0, then it should reverse direction and become +5. So what this function will do is actually make the LED get brighter and then dimmer, brighter and dimmer over and over. Notice the delay 30, that slows the process down a little bit so you could see it, but that's what this function does. And it uses analog write to send a pulse width modulated signal to the LED. Thank you.